I approached Harvard and MIT students with an intriguing question on work and energy. Without prior knowledge of the questions and no time for preparation, their unscripted answers are presented. The question is on the following slide. Do you know the answer? All right, so the question is, it takes X joules of energy for your car to go from 0 meters per second to 20 meters per second. In terms of X, how many joules of energy does it take to go from 20 meters per second to 40 meters per second? It's the same change in velocity. Does it take the same amount of energy, X, or maybe it takes more or less? In terms of X, how much does it take to go from 20 to 40?
Should be the same, right? Just X as well, right? Because kinetic energy is the same and the change in velocity is the same. Oh, wait. No, actually. So, the change in the velocity is the same, but the amount of energy... Oh, no, it should be the same. It should be the same, I think.
Okay, you were close. You were almost about to get it. Well, you don't know.
No, I think
You're
I
doing
got
great.
it.
You're doing
Okay.
really good, by the way.
I'm Yi Chen.
And where are you from?
I'm from China.
And what do you study?
Chemistry.
Chemistry?
Yes.
What year are you?
I'm a second year grad student.
Oh, you're a grad student?
Yeah.
All right.
So you need the kinetic energy difference. So that's 2 square minus 1 square over 120. That's 3.
Awesome. Very good. If you go from 0 to 20 miles an hour, let's say that takes 10 joules of energy. If you go from 20 to 40 miles an hour, how many joules of energy would it take?
Okay, and if you go from 0 to 20 and you spend 10 joules of energy, and you go from 20 to 40, your velocity, like 1/2 mv squared, if you compare the energy in each of the scenarios from 20 miles per hour to 40, you have 4 times the energy at 40 miles per hour than you do at 20. And so it would take 4 times the energy to get from 20 to 40.
Three times.
3 times. Oh, yeah.
You did it.
Oh, my gosh.
No, you did it great. You great. Good job. Good job. Okay.
It's 3 times that?
Yes. Okay. All right, so here's the answer. The work kinetic energy theorem tells us that the net work on an object equal to its change in kinetic energy. And so we're going to look at the change in kinetic energy of these two situations. So first you start out from rest, then you go to 20 meters per second. And so change in kinetic energy is 1/2 mv final squared minus 1/2 mv initial squared. And so V final is 20 minus V initial is 0. And that tells us that it's 200 m joules. Now m is the mass of the object. So a bigger object is going to take a lot more energy. It's going to take a lot more energy to speed up a semi-truck from rest to 20 meters per second than it does for a marble, for example. So anyway, so the amount of joules to go from 0 meters per second to 20 meters per second is 200 m, where m is the mass of the object. If you're going from 20 meters per second to 40 meters per second, then the amount of joules is 1/2 is 40 squared minus 20 squared is equal to 600 times the mass of the object. And so the answer is 3x. So it takes 3 times the amount of energy to speed up something from 0 to 20 meters per second than it does to speed up that same thing from 20 to 40 meters per second. I will leave it to people in the comments section to explain why it takes 3 times the energy to get the same change in velocity. All right, so you could be a winner. So there's going to be one winner, and I'm giving away 1 gold-plated silver Canadian coin. I may be giving it away. And that's if you can answer this question in the comments. So for you, what does it take? Why does it take 3 times the energy to get the same change in velocity? Simply provide a detailed explanation using physics principles in the comments within 1 month of the video's posting. The individual with the most accurate, clear explanation, as determined by me, will be chosen as the sole winner. There's only one winner. I only have 1 coin.